Hi students, ഇന്ന് നമ്മൾ ഡെറിവേറ്റീവ്സിന്റെ കുറച്ചുകൂടി ഡീറ്റെയിൽസ് പറയാൻ പോവാണ്. വേറെ പുതിയതായിട്ടൊന്നുമില്ല. നമുക്ക് സ്ലൈഡ്സിലേക്ക് പോവാം. So, more on derivatives. Because നമ്മളെങ്ങനെയാണ് differentiation define ചെയ്തത്? Suppose E is an open subset of Rn. X is a point of E. And F is a mapping of E into Rm. Assume that it is differentiable at X. Then what is the meaning? There exists a linear transformation from Rn to Rm. Call it A, such that limit vector h tends to vector 0, norm of f of x plus h minus f of x minus ah divided by norm of h equal to 0. When E is open and x is in E, x plus h also will belong to E for norm h small enough. So f of x plus h is defined and it's a vector in Rm. Similarly, f of x, it is a vector in Rm. Ah is in Rm because h is in Rn. So the numerator norm, that is in Rm, and the denominator norm, that is in Rn. So this limit is equal to 0. It is equation number 1. Or equivalently, we have seen that f of x plus h minus f of x is equal to ah plus r of h. It is 1 dash, where limit vector h tends to vector 0, norm of r of h divided by norm of h is equal to 0, where the numerator norm is again in Rm and the denominator norm is in Rn. So next slide. So how to go to next slide? Okay, and recall the linear transformation A is called the derivative of f at the point x, and it is denoted as f dash x. See, on the top of f and x you can see two horizontal lines. So it is to indicate that f is a vector valued function and x is a vector in Rn. And we will make another definition which we did not define in the last class. We say f is differentiable in E if f is differentiable at every point of E. That means if f is not differentiable at some point of E, then we say that f is not differentiable in E. Next we go to the essential uniqueness. Suppose f is differentiable at x. That means either 1 is satisfied or equivalently 1 dash is satisfied in the previous slide. Both are equivalent. Suppose 1 or 1 dash, whatever, holds with two linear transformations a1 and a2. Then a1 equal to a2. So this is what is called uniqueness. That means the derivative is unique, and its proof is very simple. you define B as A1 minus A2. Show that B is identically equal to the zero linear transformation. That means we have to show BH is equal to 0 for every H in Rn. And I want you to read that proof from textbook, and you must do it. And a few remarks. So look at the first one. F of x plus h minus f of x is approximately equal to f dash x into h. Why it is approximately equal to? Because f of x plus h minus f of x is equal to f dash x into h. That means ah plus some r of h. That r of h is there. It is a quantity tending to 0. It is a quantity tending to 0 faster than h tends to 0. That's what this shows. You have limit h tends to 0, norm of r of h divided by norm of h is equal to 0 means when a fraction will tend to 0, if the numerator tends to 0 faster than the denominator. So r of h is actually a quantity which itself tends to 0. More than that, it tends to 0 faster than h tends to 0. So you have that thing, and this quantity I am not writing. So therefore f of x plus h minus f of x is approximately equal to f dash x into h. That means the value of the linear transformation f dash x applied to h. That is this increment. That is first remark. And secondly, f dash x, that is a linear transformation from Rn to Rm, and therefore it belongs to L of Rn comma Rm for every fixed x in E. So when you fix x in E, f dash x is a linear transformation from Rn to Rm. But when you vary x in E, then f dash x will vary corresponding to that x. So it is also a function of x. So where that function is defined for x in E, f dash of x. So f dash is naturally a mapping from E into L of Rn comma Rn. So f dash of x can be viewed in two different ways. First, as a fixed linear transformation when you fix x in E, and secondly as a function of x. That is this. And third thing, if f is differentiable at x, then f is continuous at x. Why is this? Let us go to 1 or 1 dash. So what is 1 dash? F of x plus h minus f of x is equal to ah plus r of h. Now what is continuity? As h tends to 0, f of x plus h must tends to f of x. That is precisely continuity of f. I am assuming f is differentiable at x. That means 1 dash holds. Now why f of x plus h minus f of x tends to 0? Because f of x plus h minus f of x is actually ah plus r of h, and a is a linear transformation, and we have shown that linear transformations are continuous. Why linear transformation is continuous? Because you have the fundamental inequality norm of ax less than or equal to norm a into norm x. Norm a into norm x. So in particular, norm of a of x minus y is less than or equal to norm a into norm of x minus y. Right? Therefore, as y tends to x, ay tends to ax. That is precisely continuity of a. So in particular, when y tends to 0, ay also tends to a of 0. But a of 0 is 0. Hope you understood. I will write once more. Norm of a of x minus y is less than or equal to norm of a into norm of x minus y but a is linear. So norm of a of x minus y is precisely norm of ax minus ay. So norm of ax minus ay less than or equal to norm a into norm of x minus y. So as y tends to x, right side tends to 0. So left side also must tend to 0. That means ay tends to ax. This is precisely continuity of a. So every linear transformation is continuous. Therefore, when h tends to 0, this ah will tends to a of 0. But a of 0 is 0 because a is linear. And r of h, as I said, it is a quantity tending to 0 as h tends to 0. So this also tends to 0. So the right side tends to 0 as h tends to 0. That means left side tends to 0, precisely saying f is continuous at x. So differentiability implies continuity. Hope you understood. So 3 says differentiability implies continuity. And fourth remark, the derivative is also called total derivative or differential of f at x. This is called a total derivative because there is a concept of partial derivatives which will be coming later. Okay, so next we discuss. Suppose we start with a linear transformation. A from Rn to Rm. This is also a function from Rn to Rm. And for functions, we have defined what is meant by the derivative. So the question is, for a linear transformation, what is its derivative? What is the derivative of a linear transformation? And here is the answer. You have a of x plus h minus a of x. Because of the linearity of a, it is a of x plus h minus x equal to a of h. And a of h can be written as a of h plus 0 of h. Vector 0 of h. What is vector 0 of h? It sends everything to 0. 0 h is the 0 of h. is equal to 0 for every h in Rn. That means 0 linear transformation. And we have observed that if such an A exists, then it must be unique. And this is called the remainder. This R of h equal to, here it is 0 of h. It is called the remainder part. And it should have the property that limit h tends to 0, norm of R of h divided by norm of h must be equal to 0. That means R of h must tend to 0 faster than h tends to 0. Such a thing should exist and it should satisfy this property. If that holds, this is equivalent to saying function is differentiable. With the derivative, here function is a, so derivative is denoted by a dash of x. So what is a dash of x? Precisely your a of h. Derivative is a. So we can use 1 dash to conclude that a dash of x must be precisely this a. A dash of x is equal to a. This is by using 1 dash. We can use 1 also. How do you use 1? So 1 is limit of this quotient is equal to 0. Again, since a is linear, a of x plus h minus a of x will be equal to a of h. Therefore, the numerator a of x plus h minus a of x minus a of h is equal to 0. Norm of 0 is 0. So limit is equal to 0. So this condition is met. Once this condition is met, this function is differentiable with the derivative this, that is using 1. So what is a dash of x? What is a dash of x? It is precisely this thing. So a dash of x is equal to a. So either you can use 1 dash or you can use 1 to conclude that the derivative of a linear transformation is the linear transformation itself. So a dash of x is equal to a itself. Hope you understood. Now let me ask you a question. Let us take a function from R to R defined by f of x is equal to 2x. Is it linear? It is multiplication by 2, therefore it is linear. F of x plus y is equal to 2 into x plus y equal to 2x plus 2y equal to f of x plus f of y, and f of cx is equal to 2 into cx. It is c times 2x equal to c into f of x. So f of x is equal to 2x is linear. What is f dash x? You will write f dash x is equal to 2, right? F dash x is equal to 2. Just now I said the derivative of a linear transformation is the linear transformation itself. But here the function I started with is f of x is equal to 2x. It is linear. And look at the derivative. What is the derivative? It is f dash x is equal to 2. Is it linear? Linear or no? F dash x is equal to 2. In the original, is it linear? No, it is not linear. Then in what sense I am saying derivative of a linear transformation is that linear transformation itself? Actually, you have to think over it and We will discuss in the discussion forum. If any of you get the answer, please reply in the discussion forum. Otherwise, I will ask you in the discussion forum, or we will meet in the Zoom or Moodle site itself in a video conference. Okay, thank you.